In our last class, we went over percent error, and I tried to show you some different ways to approach this problem, and I left class feeling like I just kind of made it more confusing. So I just wanted to go over like just one or two methods for the first two questions. I will tell you that number one, okay, when we get to our assessment, number one is really what the test is going to be, the question on the test is going to be about. It's going to be giving you two values. It's going to be giving you like a predicted value and an actual value, and you have to find the percent between them. So this is the one you really need to make sure you know how to do. I'm going to show you one using the formula and two using our percent equation, and hopefully that'll be clear up any misunderstandings, and then I'll do number two as well. So I've got the formula listed out there. If you were to look this up, you know, there's different terminology that goes along with this. Like the actual value, you know, sometimes that's called the experimental value. Sometimes that's going to be called the actual value. We got actual. Sometimes it's called the exact value. Sometimes it's called the measured value. It's what's actually happening or what you're actually measuring when you do whatever it is that you're doing. In this case, what the actual measurement is going to be is the 102.8 because that's the true speed of the baseball in this one. The theoretical, or sometimes this is called the predicted value. Oh. The predicted value, or sometimes it's called the estimated value, but the theoretical is 103. That's what the radar gun is predicting that the speed of the ball is, and it's a little bit off here. So if I was going to use this, I'm going to take 103, the theoretical, minus 102.8, and we have those absolute values around it because we're looking for the difference between these two numbers, but we don't care if it's positive or negative. So I'm going to take that divided by the actual, which is 102.8. And then that's going to give me the decimal, but I have to multiply it by 100 in order to get the percent error. I should put my equal signs in here, and let me just label it percent error. Okay, so if I go through, I've already done this calculation, but I end up getting 0.2 in the numerator divided by 102.8. And that gives me a really small decimal. It's like 0.0019. And then when you multiply it by 100, it moves that decimal place over two places, and it gives me the percent error of approximately, I am rounding here, so let me erase that, to approximately 0.19%. So that's how you would use the formula, and you're perfectly welcome to do that once we get to the test. Now, some of you are more comfortable with those other methods that we've been working with in class when we're looking at percent increase and percent decrease. So what I'm really doing right here is I'm going to describe this using the percent equation, but I'm trying to find, like, let me write it in words first. I'm trying to find the difference. Difference is what percent of the actual value. Like, I want to know, like, how far away am I from the actual value? But I'm going to be measuring that as a percentage. So in this problem, the difference, you can see that's listed right here, 0.2. So I would have to subtract the two values. I'm always going to be positive. So what this question becomes is 0.2 is what percent? That's what I'm trying to find. So let me just put a P right there, of the actual value. So the actual value in this one is, again, remember, 102.8. So times 102.8. All right, and then that's a one-step equation. I'm going to divide both sides by 102.8, 102.8. And at this point, I don't really need to do any further calculating because you see I've already done 102.8 divided by, or 0.2 divided by 102.8 right up here. So I've already kind of gone through and done that calculation. This, well, let me put it down. This would have given me P equals 0.0019. Okay, so and it keeps on going. But I would then have to convert that to a percentage. The formula's kind of got that built in already by doing times 100. Okay, you would need to remember to do that yourself if you were using the percent equation. Okay, so those are two ways that you could approach a problem like number one. And like I said, number one is what it's like, the one on your test going to look like. Okay. If I was going to apply, I'm just going to use this second method right here for number two. So again, let's write it out. The difference is what percent of the actual. Of actual. All right, so on number 2, we don't know what the difference is because you're told like how long it takes you, okay, to actually drive downtown. It takes 48 minutes, but there's no way that you can find the difference because I don't know what the app was actually predicting. So let's just call that, I'm just going to call that X for that represents the difference, okay? So X is equal to what percent? Now in this problem, you're told what the percent error is, okay? The percent error is 20%. So what percent, so that would be 20 out of 100, okay, of the actual value. And we know what the actual value is. The actual value is 48. So really what I'm doing is I'm taking 20% of, or times, 48. Okay, 0.2 times 48, you stick that into your calculator, it's 9.6. Now 9.6, remember, this is the difference, okay? So if it actually took me 48 minutes, but the app was estimating something less than that, okay, I need to take 48 and then take away the 9.6 because the 9.6 is the difference, okay? So then I do 48 minus 9.6 and that gives me 38.4 minutes. So this right here would have been what the app was predicting. Okay, so those are there's 2 examples. Hopefully that makes it a little bit clearer if you weren't sure. But if there's one of those you really need to make sure you know how to do, it is number 1 because that's what you're going to be assessing.